Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 5 from lesson 6-2 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to use 2 points to find an exponential model. Alright, so what I did was I actually screen capped a whole lot from the textbook here, just explaining stuff. And then I'm going to use that. I'll walk through with you on how they do that, and then we'll try it on another one. So it says that Tia knew that the number of emails she sent was growing exponentially. She generated a record of the number of emails she sent each year since 2009, and they want us to find an exponential model that describes the data. All right, so the biggest thing here is making sure that we recognize these are 2 ordered pairs. Okay, so we have these 2 consecutive years, and it says the number of years since 2009. All right, so my 2 kind of ordered pairs I have going on here. 2009 to 2015 is 6 years. So I have 6 comma 1000, and from 2009 to 2016 is 7 comma 1400. So just be aware, those are my 2 ordered pairs I'm dealing with. Okay, so the formula that I'm going to be using for this exponential model is this one here. All right, where we're not necessarily talking about much in terms of rates. There's no compounding going on. This is just a basic exponent. Okay. So y is equal to the number of emails in hundreds. So what they're doing here, y'all, is they're just dropping some zeros to make their calculations less annoying. So here I'm dividing each of these by 100. And x is the number of years since 2009. So that's where I got the 6 and 7 from. So the first thing, like in order to write this model, right, we need a number for A and we need a number for B. Okay, so that's our goal. Now finding B is actually really easy. Okay, so since we have what are called consecutive x values, that means one next to another. So 6 is next to 7, so they're consecutive. What you could do is that you could describe the growth factor, this B value, as the ratio of the y values. So all that they did was they took the 14 and divided it by the 10. Now it's important that you guys are doing 14 divided by 10 and not 10 divided by 14, because 14 is after the 10, essentially. Like on the model, 7's after 6. So this is the right-hand point divided by the left-hand point. Okay? That's their point there. Anyway, so they did 14 divided by 10, and that's where they got 1.4 for their B value. Okay? So now once we know what B is, the only other thing we're looking for in the equation is A. So what they're doing is they replaced B with the 1.4, and then they picked one of our 2 ordered pairs. It doesn't matter which one. They chose 7. So they took 7 comma 14 and plugged it in for x and y, so that A is the only number that's not solved for in the equation. And so then they took 14 and divided it by 14 to the 7th power, and that's where they got A from. All right, so once they knew A and B, they just plugged it in and got that equation. All right, so we're going to do that same thing here with this surveyor. So it says, a surveyor determined the value of an area of land over a period of several years since 1950. Okay, that's our big thing right there, right? To generate our 2 ordered pairs. So in 1954, which is 4 years after 1950, the land was worth $31,000. And then in 1955, so 5 years after that, it was worth $35,000. Use the data to determine the exponential model that describes the value of the land. Okay, so there we have it. So I'm going to change this to being in thousands, okay? So when I go to write my sentence out, the function blah, I'm going to leave some space there for that, for me to insert my function, essentially. It's going to model the value of the land in thousands X years after 1950. Okay, so in order to drop my zeros, I need to put the caveat in my answer saying that the y value here is in thousands. Okay, if you don't, then you're going to be kind of misleading people. Okay, so there we have it. So by saying it's in thousands, what I did was I eliminated these zeros here so that I'm not dealing with such big numbers. Okay, so first step is to find b. So b, my growth factor, is going to be the second number divided by the first number, so 35 over 31. Now I have the feeling that's going to be like a kind of ugly, not friendly number. Yeah, ugh. So I'm just going to leave it as 35 31st. Why not? Okay. Now I can round that to decimals. I guess I will. Now when I go to calculate A, 1.129. Sorry, I only have a couple of brain cells. There we go. So when I go to calculate A, I'm going to keep it as 35 31st, just because when you round, it really changes things. But when I go to plug it into the equation, I'm okay with leaving it as 1.129, okay? In fact, if I check out Savvas, curious at what Savvas does. When Savvas writes their answer out, they put it in as 1.13, so they round it even further to the hundredths place. So for the sake of continuity, I'll do as Savvas does. Okay. So now let's go ahead and let's solve for A. So to find A, I'm going to pick one of these points. I'm going to pick 5 and 35 because that's friendlier. And I'm plugging it into this main equation. So I get 35 equals A times my B value. Remember, I'm keeping my B value as the fraction for now. And I'm raising it to that exponent of 5. So to find A, what I'm doing is I'm taking 35 divided by 35 31st to the 5th, and that'll get me A. Okay, and so I'm looking for that approximation. So let me take a screenshot of this, because y'all know I can't remember numbers to save my life. And let's see how to plug this into Desmos. Well, so there I already have 35 divided by something, so let's put that 35 31st in parentheses, and then raise that parentheses to the 5th power. Now be careful when you're typing it into Desmos that fifth power is only applying to the denominator there, and that it's not applying to the whole numerator. Okay? And so I'm taking a screenshot of what Desmos is showing me. That way if people are looking at my notes later, they'll be like, what? Huh? So in this case, my A is approximately 19. Okay? So when I go to model this function, I'm going to say y equals my A. For A, I'm putting 19. Now, because I put the caveat of in thousands, that's why I could put 19. If I don't put that in thousands thing on there, I'd put 19,000. Okay? Savvas doesn't do that. Savvas doesn't even mention the in thousands. I don't like how they're changing their answer there, so I'm going to go ahead and change what I'm doing with Savvas, and I'm going to just put the 19,000 in there. That way it's the same thing, it matches, and we're friendly. So there's my 19,000. And then times 1.13 to the x. Should have left more space for myself, but there it is. Alrighty guys, so that's using 2 points to find an exponential model. In the next video, Savvas actually created their own video to explain regression for exponentials. So I'm not making an example 6 video. There you have it guys, have a great day.